All right, so what we got going on today is we've got a motor that we pulled out of unit yesterday. We replaced the entire pump with the pump already had ready to go. And we're going to go ahead and repair this motor and just put it on the shelf for another job, save somebody some money on a refab. Right now, if you're looking at retail prices on large horsepower motors, say from 2 to 5 horsepower, you're going to be looking at $500 to $600 range for a complete pump. Where we're paying nowadays, we're paying wholesale what we were selling for retail 2 years ago. With a good set of bearings in it, this motor should last over 20 years. What most of them die from are a bad shaft seal. That's where the motor shaft goes into the actual pump itself, and that's what happened to this one. And what happens is the cooling fan draws that motor out. It ruins the front bearing of the pump, and then the pump's got to be rebuilt. A lot of times people let them go too long, the shaft gets so rusted out or the motor gets in such poor condition that it cannot be repaired. But this is going to be a pretty easy little repair job on this one. We're going to slap 2 bearings in here and it's going to be good as new, maybe better than new. All right, so this is Jason Wright, my future son-in-law. He's engaged to my daughter, and he helps me from time to time. He's going to be taking this motor apart and showing you how to replace the bearings in it. So why don't you tell them what you're doing, Jason?
So first I'm going to make some witness marks on these end bells to the barrel, so when we're reassembling it, we're not searching forever to get the through bolts lined up.
Right, and that keeps the end bells clocked in the correct position so that we can just slip the bolts in and lickety split. So show us how you do that.
So you take a flathead or whatever you got that's hard, and your multi-tool here.
Lineman hammer.
And just give it a tap. You got a nice clear line.
If you make more than one, it makes it easier, so then you don't know it's not an accidental mark, that's the mark that you wanted. We got the witness marks all made up and we're ready to go ahead and start disassembling the motor. Just tell them what you're doing, Jason.
We're going to take this bolt off to get this cover off so we can get to the through bolts. So take through bolts out and get it disassembled.
All right, cool, let's do it.
That's that.
All right, it's kind of windy today. I hope that noise isn't bothering anybody.
And I got 4 through bolts here, 1 on each corner.
All right, that little magnetic bit really helps, pulls them out of the motor for you.
Yep.
All right, now what do we do?
Now we tap her apart.
All right. We always start with this rear end bell, and you're going to see why once he gets it off. Because there's a switch inside of there, and if you don't take this off properly, you will destroy that switch, and that'll be the end of that motor. All right, he's getting it past.
There we go.
All right. So he got her loose. The rotor out. Wire's kind of tight in this one. Normally you have a little bit more slack than what this has. So he just broke that front end bell loose, and he's going to go ahead and pull the whole rotor out. The way this works is this is like the centrifugal clutch on your go-kart when you're a little kid. So when this motor's at rest, this is out, and what it's doing is holding a switch closed inside the motor. And once the motor starts spinning, it gets to a certain RPM. That'll be determined by the way the springs, the weights fly apart, and the armature drops away like that, turns the switch off. If this is broken, this motor will start up, but it will just burn up within a few seconds because it won't disengage the start capacitor. So at the very minimum, the start capacitor will explode. You'll have to replace that as well as replacing that rotating switch, which again, unless you have access to a commercial distributor like Brownell or somebody like that, you're not going to be able to get those parts. You might. These should have a little bit of drag on them, just like a wheel bearing on a car. They shouldn't just spin free like a widget spinner or something.
Like that
and
one.
like the front one is doing. And if we had this motor running, when this motor's running, that bearing is screaming. So just go ahead and show them how we get that front end bell off, Jason. So there's a little keeper, and you don't need to take the screw all the way out. You just need to loosen it, and that keeper will move away, and then you can drive the front end bell out. And this this controls the thrust of the motor. There you go. That's coming off a little bit easier than it should, but I don't think that the end bell's worn. I just think there's a lot of grease that leaked out of the bearing as it went bad. And so there's that little keeper, and show you how that works. Here's how this little keeper works. When you tighten the screw, it floats around like that and locks the bearing in place. And when you loosen the screw, it just moves to the side. It's a pretty simple little device. Here's that bad front bearing, and you can see she's continuing to spin after let her go, and it feels like I wish you could feel what I'm feeling right now. Because it imagine having sand between your teeth, and that's what that bearing feels like when you're moving it back and forth.
Pretty horrible, accurate description there.
There you go. All right, now we're going to go ahead and start pulling the front bearing off, and this does require a special tool on an A.O. Smith or Magnatech motor and a lot of other motors, because the cooling fan is so close to the front bearing. There's no way to get a standard puller underneath of it, and let me show you that. So the clearance is only about probably less than a ½ inch here, and so you actually need this special tool to snap over that bearing, and then your puller actually connects to it right here. So you're moving away from that fan. You're not trying to force the jaws of your puller under that fan and break it. And these plastic fans will break very easily. One thing you want to do when you're pulling these bearings off is you don't want to put any force on the end of this shaft. This is only a 7/16 shaft to begin with, and it's even thinner right here where the threads are, relief is cut behind the threads. And so what you want to do is you actually want to pull on it. You want the force to be right here on his shoulder. Now this is a commercially available armature protector. This is what it's designed to do, but as you can see, it doesn't actually go all the way to that shoulder. This is actually for a different size motor. It's for a like a 56C. But what we use, which works very well, is a 3/8 inch quarter drive deep socket. And what that does is it allows the puller to go up against that shoulder, and so we don't have any force on the end of the shaft or those threads that would bend that shaft or damage those threads. All right, now Jay's going to go ahead and put that adapter on there for us, and it just opens up like a clamshell. And now there it is. So we're moved out away from that cooling fan. We're not going to damage the fan. And go ahead and get your puller ready, Jay. When you do, we'll film you some more. He's got the adapter on. He's got the puller all set up. We're just using this small 1/4 inch Milwaukee M12 impact, and that should pull that bearing. And she's off. Easy peasy. Lemon squeezy. This end has a live center cut in it. So we may need to take our adapter off so that the puller doesn't walk around, but that's kind of pain in the neck. So he's just gonna go ahead and try it with that armature protector on, and if it walks around, we'll take it off. She's walking around, but he's getting her done. And she's off.
That's a bad bearing.
That's the bad bearing. You can see it got hot, all the grease is running out of it. And these are 6203 LL. LL stands for double sealed. And they are 40 millimeters by 14 millimeters by 17 millimeters. Go ahead and start putting some bearings in here. And we only use Nachi bearings if we can help it. They're very high quality bearing from Japan. They're not that expensive, and I've never had a problem with them. I have had problems with other bearings. I've had bearings that are galled and damaged right out of the box. So you get what you pay for. These are not cheap, but they're also not very expensive. They're a good mid-grade solution. They're a high quality bearing, and like I said, we've never had a problem with them. And it's what we use exclusively when repairing or rebuilding motors. So why don't you go ahead and show them how we install bearings. Pretty simple. One thing you got to check for, pull it back off one time, Jay. One thing you got to check for is when you take this apart, sometimes there will be shims behind the bearings, and there's actually not one on here. There's one that's actually machined into the shaft, but sometimes there are actual physical shims in there. So you want to make sure that you put the same shims back in that you took out, or the thrust may be off on this. These motors are not super critically, these motors are super precision motors, but if the motor's not shimmed properly and the thrust is off, if the shaft is too far forward or backward, either you'll have a shaft seal that won't stop leaking, or you'll have a shaft seal that prematurely fails because there's too much tension on it. So let's go ahead and drive those bearings on. So now the front bearing, you can kind of stand the motor up. You're not going to mushroom that shaft to just the little amount of force that you're using to drive this bearing on. It's easy to use a pair of lineman pliers. We don't even use a hammer.
That should be it.
Then you can hear it when it bottoms out. Driving on here, and he's going to check to make sure it bottomed out. It sounds like it did. That sounded good. And yeah, look, from where I'm looking.
Yeah, it looks good.
Yeah, from where I'm looking, it looks pretty good. So we're going to put the rear one on. This is a little more tricky. I'm sure somebody makes some kind of super duper special tool to do this. But what we do is we hold that shaft against our knee like that, or thigh like that. And if you don't punch a hole in your thigh or break your femur, you're probably not going to damage the end of that shaft. So it takes a little bit of like I said, these bearings should just slide right on. They shouldn't take a whole lot of force to drive them on. All right.
Sounds like
yeah, she went home. So you could use a bearing warmer or something like that, but it's really not necessary on a. It's really not necessary to use a bearing warmer or something like that on these bearings. And again, most of the time we're doing this in the field. I mean, we might be doing this in the rain or something. So we just drive them on with the 203 driver. That's what the driver's designed for. And you may be able to order those online or something. You could also maybe just make one out of a piece of pipe or something. But I think they specifically the driver's softer than the bearing race, so you're gonna mushroom up that driver and not bust up your bearing. And you can see how mushroom. This one's old. You can see how mushroomed out it is. She's put a lot of bearings on. That's made me a lot of money over the years. Jason's ready to start reassembling the rotor here. He's going to start with the front end bell, and it should just kind of walk on there by hand. And you heard that thing snap home. All right, Jason, go ahead and tighten up that keeper. I don't think we can show the keeper moving, but just go ahead and show them what you got to do here, Jason. And that's it. And we always check the torque on everything with hand tools. We use these little drivers to just to put things together and to snug things up. And we always make sure things are tight by hand. Looks good. All right, let's put her back in the motor barrel. All right, so Jason's about to put this this rotor back into the motor barrel. And go ahead, show us what you're up to here, Jay.
Gonna ease it up in there.
And he's gonna spin it around, look for his witness marks that he made before. Sorry about the lighting, folks. I'm not a camera guy. There we go. See if we can get a close-up of that. Well, we don't really need to. They'll see when the bolts go through it. This is a thrust washer, and this goes down inside the end bell. It's kind of hard to access, and what you see, it's wavy, and what that does is it's a spring, and it keeps tension on the shaft, pushing it forward. Just an added effort to make sure that the thrust stays good on this. All right, so he's got his witness marks lined up, and he's just going to try to tap on the center of that end bell. Just tap her on home, so she's nice and tight. And does it spin? We know this motor ran when we took it out. It was just all noisy as get out, so we're just going to go ahead and put the volute back on there to hold the motor together. The volute will not be reused, or volute. Different people pronounce it different ways. And we'll put it on the shelf, and it's going to save somebody a lot of money. We'll probably sell this motor for $125, $150, and it's going to, you know, might make somebody's budget, might make somebody's holiday, getting their spa back in operation when they really couldn't afford a $400 or $500 or $600 pump. Jason's putting the through bolts in. He's going to make sure they go all the way through and catch that volute. So all we need now is a little 1/4 inch nut driver. All right, good. You can see that end bell pull in a little bit as you tighten those. And you don't want to over tighten. You will pull the inserts out of the volute. It looks good. Now, let's see how good a job Jason did. I'm going to take this little flathead screwdriver here, and we're going to see if this motor turns or not. Look at that, like butter. It turns easy, but it's not too free. This motor's ready to go back into service. Like I said, it's just a simple repair. You know, you can go online and order up yourself an adapter for that 203 bearing for the clearance on the cooling fan. And you can do this at home yourself and save yourself a lot of money. If we were doing this in the field, this bill would be at least $300, maybe $400, depends on whether we had to drain the unit and refill it when we got done. So definitely something you could do to save yourself some money. And a lot of companies nowadays, and I don't blame them, won't do these repairs in the field because of callbacks and things like that. They'd rather sell you a new pump, and I don't blame them, because at the end of the day, that's a superior repair. You're getting something that's brand new. It's got a manufacturer's warranty, and they don't have to do the warranty on it out of their own pocket. So, but for me, with limited space, I can repair probably 90% of the motors, pumps and motors I come across with one milk crate full of impellers, 4 different seals on the truck, and 2 different size bearings. We do run into 304s and 204s from time to time, but pretty rare. Most of them are going to be 203 LLs or 20310s. So that's it. All right, Jason, say goodbye.
See ya.
All right.